Hi. Okay, I think it's time to start with today's lecture. Uh, I hope you already have submitted the assignment one, and I don't know if you have noticed or not. I have uploaded the assignment two this morning. So, and just to give you an overview of this assignment, you can find the assignment, the next assignment, yeah, in the assignments part, and yeah. And there are, in the assignments part, you will see like there are 3 different files. The description for the assignment exercise is in the PDF file. And the zip file, it provides you with some supporting material regarding some interface definitions, which you are required to implement during the different tasks in the assignment. And these assignments mainly involve, yeah, sorry. So here, if you go here, if you go there, and here you will see this file, the PDF file. It provides you with the task description. So basically, the assignment targets the JUnit testing, which we will cover today, and inheritance. Plus, it will also cover some part of the data structure that we will cover in the next lecture. So just go through it, and if you have questions, of course, you can contact Maria. And I think we will have a lab session. Is it tomorrow or when is it? Tomorrow, yeah. So my advice is that before going to tomorrow's lecture, just the lab session, go through all the tasks, and if you find some ambiguities or if you have some questions, then you will have a good opportunity to ask those questions during the lab session. And as I told you, that some of the tasks involves the data structure part, so don't worry. If I mean, we have covered some basic information about the data structures when we was talking about the collection framework. We have looked at the set interfaces and the set implementation, like hash set and the tree linked hash set, and the map data structure. So, and we will cover more details in the follow-up lectures as well. Okay. And then coming back to today's lecture, in this lecture we will talk about exception handling, what the exceptions are, and then in the second part we will talk about testing, software testing, and what is unit testing in particular. And we will use JUnit, which is a tool or a set of libraries for unit testing in the Java. So, beginning with the exception part, can someone tell me what is an exception? Do you have any idea before beginning? Anyone? Yep. Okay.
It's an error in the program.
It's an.
That was not anticipated.
Sorry.
That was not anticipated.
That was not.
Normal execution.
That was not anticipated. It's an error in the program that was not anticipated. Someone else would like to add more? Yep.
Actually, it's a prediction to avoid an error.
It's a kind of a prediction to avoid an error. Yeah, it's a kind of precautionary measures that the programmers can take to handle runtime errors. So it's a way of, I mean, if you want to simply define what an exception is, it's an abnormal condition, or something like that is not expected. I mean, of course, it might be expected. Sometimes you are expecting these kind of things, but it's not that's like the ideal behavior of your program. So in simple words, we can say that it's an abnormal event or condition which could happen at runtime. The important thing is that the exceptions they happen at runtime. They are not like syntax error or compile time errors. And it will if you are not handling the exceptions properly, and there is an exception in your program, it's like a bug or an error, and then it will disrupt the flow of your program. Your program execution will stop, and the Java runtime system will provide you with some information about the error. So in other words, we can say that exception is a runtime error. And a common example of exception in Java, or maybe in other programming languages, is that if you try to divide by 0, which is an illegal operation in Java. So if you try to do some division by 0, it's not a syntax error, but you will get a runtime exception. So for example, if we look at, I have some examples codes here. So if we go here, we have a simple class where we have just a main methods, and then a divide method, which simply takes 2 input values and return the result. Okay, and if you see that we have the 2 values 7 and the other one is 0, and here we are not handling these kind of exceptions, so there is no error here. There is no syntax error. But if we try to run this program, so if you can see that in the output console, yeah, the Java runtime system, the JVM, it gives us this information. It says that exception in thread main, and then it specifies the type of the exception. So there could be different types of exceptions depending on the operation you are performing. There could be different types of error conditions. So, and then if you have not specified any code to handle these exceptions by yourself, the JVM, the JDK, it will provide you with the default kind of exception handler. And this kind of exception handler will provide you with the basic information that what kind of problem with your code is, or what kind of runtime error is. And if you see here, it says that the java.lang.arithmetic exceptions divided by 0. So you can, and also it points you the line number where the exception has occurred. So in this case, it says like you have a problem at line 13. So if you go to the line 13 here, we are trying to divide, but since the value of q is 0, so it gives us this exception condition. If we change the value from 0 to something like non-zero, there should be no problem. Okay. So that's a simple concept of exception. But then moving forward, there are two basic types of exceptions. One we call checked exception, and another one we called unchecked exceptions. The difference between two is that, as the name indicates, that there are some exceptions that Java compiler forces us to handle when we are writing the code. So, and these kind of exceptions, they are often known as like that we already know that this kind of exception might happen, and these kind of exceptions are required to be checked at compile time. So example of such kind of exception is that file not found exception. And the Java JDK requires that this kind of exception must be handled using either try catch or finally, or using throws class. On the other hand, we have unchecked exceptions. The unchecked exception, as the name says, that the Java compiler doesn't forces you to mark these kind of exceptions. So you can, for example, if you look at this program, we have not defined any throw class, or we have not defined any try catch block. So there is, and there was no error. Compiler was not asking us or not forcing us to take any operation or to take anything. So this kind of, the division by 0, for which the compiler doesn't require you to provide any exception handler. These kind of exceptions are known as unchecked exceptions. And on the other hand, the exceptions that require you, for some cases that the Java compiler requires you that you must provide an explicit exception handler, try catch block, or a finally block, or maybe you should throws, declare that this block of code is going to generate an exception. So that kind of exceptions that are checked by the compiler, simply they are known as checked exceptions. So an example maybe of this kind of exceptions could be like, for example, if you have another program where we have, maybe we should look at it later. Coming back to the checked and unchecked exceptions. So one basic rule about that, the checked exception, they must be handled using either try catch or finally. Otherwise, the compiler will complain and it will say an error. For example, if you have a file not found type of exception, so for example, if you look at this code now, we have a class read file which is trying to read some file, and if we go here, we have written this code within the try catch block. But if I remove this try catch block, if I comment this one, and then all the way down. Now if we go here and if we look at what's the problem here, it says that unhandled exception type file not found exception. And the suggestion, if you look at that, it provides you two quick fixes. The one is that add throws to the declaration. The other one is that surround with try catch block. So these kind of exceptions for which the Java compiler generates an error and requires you to handle to provide with some kind of exception handler. They are known as checked exception, because for these kind of exceptions, the Java forces you to provide the Java compiler checks, and it forces you to provide an exception handler. And that exception handler, you can, one simple way might be that you add a throws class. We will talk about later what the throws class is, and specify the name of exception, the expected exception that in this method could be. So for example, file not found exception. Okay, but then in that case we need to import this file not exception. Import IO. Yeah. Okay. So one way is that you can declare, you can avoid this kind of problems using throws class, because now we have told that this throws class tells us that the users of this method, that in this method we have a part of code that could generate this kind of an exception. Another way, if you don't specify, to avoid this kind of exception, is that you need to provide something that can handle such exceptions. And the mechanism provided by Java to handle this kind of exceptions is using the try and the catch blocks. We will look at how we can use try catch in Java to handle exceptions later on. Another way to remember about what are the checked exceptions and what are the unchecked exceptions. If we look at the hierarchy of exception classes, there is a throwable class provided by the Java API, and all your exception classes must be subclasses of this throwable class, because the exceptions are thrown at runtime, and this throwable provides with the basic behavior. And this throwable class has two subclasses, exceptions and error. Can someone tell me what is the difference between exception and error in Java, if we're talking about errors and exception in Java? What's the difference between the two?
Error should be, for example, syntax.
Mhm.
Something completely wrong, while exception should prevent errors from happening.
Exception prevents
Errors from happening.
Yeah, exception handling could be, but the basic difference is, I mean, between the errors and the exceptions is that both are the subclasses of throwable, so they have some similarities between them, and both represent abnormal conditions at runtime or an abnormal event which was not required. But the difference between the two is that errors are normally the conditions which cannot be recovered, which you cannot be handled. They are more serious kind of problems. So for example, if your application requires an access to some hardware resource, and there is a problem with the hardware resource, for example, if you are using if you are getting some data from a printer, and there is a problem with some printer, and these kind of problems which you cannot handle, they are normally treated as errors. So in other words, the problems or the abnormal conditions, the more severe, the more serious problems or events which cannot be handled at runtime, they are the errors. But on the other hand, the conditions that we can handle that are not so severe, which can be handled and can be recovered at runtime, they are considered as exceptions. And both errors and runtime exceptions and any class that is a subclass of these two classes, they are kind of unchecked exceptions. So it means that the Java doesn't require you to handle these kind of exceptions, because as we talked about in the beginning, that handling the severe conditions or the problems or the errors is not, these are not kind of recoverable at the runtime. So and that's why the Java doesn't forces you to specify the try-catch block for the subclasses of error and runtime exception. But on the other hand, exception and all other its subclasses, you can define your own kind of exception classes by making them subclass of, by extending them from exception class. And in that way, if you have inherited a class from the exception class, it automatically becomes a checked type of an exception. But if you want to have a class or an exception to represent an exception condition, that doesn't require to be checked. So then you can inherit it from either the runtime exception or from the error. So there was some fundamentals information that we have already discussed about. A few more points about the exceptions is that the Java handles errors and other exceptions using exceptions. So both errors and recoverable and irrecoverable errors, both are treated as exceptions. And what is an exception? Whenever there is an abnormal condition within a method, the method generates an object, and that object is of type exception, and that object provides more information about the problem. So it's an exception is an object that encapsulates or wraps an information about the problem or the unacceptable or unexpected event condition at runtime. So in other words, we can say that errors are equal to or something like program throws an exception. And an example is that you often have met with the very unlikely exception, null pointer exception. So if you have created an object but you have not initialized it yet, so that object will be pointing to the null, and if you try to access that object, you will get a null pointer exception. And similarly, if you have created an array of size 5, but if you are trying to access an element beyond the size of the array, for example, if you are trying to access or insert an element with the index value more than 5, then you get index out of bound exception, because that's not something that can be expected. So whenever an exception is happened, what does the Java exception handler mechanism do? Because there could be, like, you may have multiple methods, and one method may be calling another method. So and when exception happens within a method, the Java compiler checks whether that method provides an exception handler or not. If it finds an exception handler in that method, it will use the exception handler from that method. Otherwise, it will go back to the method which calls that method. So that's like a method call stack. For example, if we look at the example over here, the simple one, we have two methods here, main, which is calling the divide method, and the exception has happened in the divide method. So when we run this one within a value 0, the Java exception, the default exception handler mechanism first goes to the method in which it finds the exception, and it tries to find the exception handler mechanism in the divide method, If it doesn't find any exception handler mechanism in that method, it will step down to the method which calls this one. So in that case, the method which is calling the divide method is the main method, but unfortunately, there is no mechanism provided, neither in here in the main method, not in the divide method. So you can solve this kind of problems by writing some exceptional handler mechanism. So if you have written the exceptional handler, you can write it in the method where the exception happens. Alternatively, you can also write it in the main method, yes. Now, if you see here, you have write a try block, but you get a syntax error. Insert finally to complete block statements. So the try statements cannot be used as alone. It requires either a catch or a finally block associated with it. So one simple way is that we write a catch part. Yeah, it's kind of using a different keyboard is always problematic. Try. Method must return, yeah. Okay, and here you can provide some information about the exception. Either you can use a println and then just pass out the exception object. So there is one way, but now if you run this, maybe we can provide more meaningful information. 0 is something like that. Do you see the difference between before and now? Because now you have provided an exceptional handler which provides you which doesn't which doesn't disturb the execution of your program. Instead, it provides you with an opportunity to fix the abnormal condition. Okay. So if you look at this step, what happens if we don't have this kind of a code over here? For example, if I comment this everything over here and put back the previous one, return p divided q, simple as that. There was no syntax error. There was the program at when you write the program, the compile time, you get no problem. There is no error indication. But when you run the program, there happens an abnormal condition due to this value of divisor is 0, and we know that this kind of operation cannot be performed. So due to that, you get an exception condition. So the Java compiler tells you that there is a problem in your code. But then to handle these kind of exceptions, if there is no exception handler provided, JVM calls default handler, which displays a string describing the exception. So you get a string message that describes the exception, and then it prints the stack trace from the point at which the exception occurred, and finally it terminates the program. So there are three things. The first thing is that it provides you the information about the exception. Then it provides you with the stack trace, the order in which the method has been called, and in which method the problem has been occurred, so that if you want to find the problem and if you want to fix the problem, you can do that. And then it terminates the program. So if we go back here it provides you with the information. Here it provides you with the stack, and then finally it terminates your execution of the program. But what we can do is that we can handle this kind of situations using try, catch, and finally blocks. These are the keywords defined by the Java JDK to handle these kind of situations where we can have a problem at runtime. And simply, what is an exception handler? It is a piece of code which is written to manage or to deal with the abnormal conditions or exceptions. The general syntax for the try catch block is that you start with wherever you find that if you have a code that you suspect that in that code there might be an exception, there could be a problem. So you must write that code within the try block, especially if you are writing something if you are expecting the checked type of an exception. And then you can have followed by with the try, you can have multiple catch statements, and in the catch statements, the multiple catch blocks, they are used to handle different kind of exceptions, because in one program you might have more than one kind of exceptions. Right now we have seen only one kind of exception, which was arithmetic exception, but there could be another kind of exception such as file not found exception, array index out of bound exception, null pointer exceptions. And if you want to handle those exceptions differently, because they are of different types, so you might have a different kinds of strategies to deal with those exceptions. So to handle these kind of exceptions, you can have multiple catch blocks. And in the end, after putting any number of catch blocks, there is an optional finally block. And the finally block, it says that the block of code to be executed after the try block ends. Remember that when you have written a try catch block, there might be a possible that in that block there is a possibility that an exception may happen or it may not happen. It doesn't really require that if you have written a try block, there is always an exception in that block. If there is a no exception, then none of the catch block will be executed. The catch block will be executed only when its matching exception has been generated or thrown in the try block. Otherwise, it will go in a sequence. So it will check the first catch exception, and if it finds an exception of that type in the try block, that catch block will be executed. Otherwise, it will go to the next catch. And if none of the catch blocks matches with the exception thrown in the try block, it will go to the finally block and execute. The difference between the catch and the finally is the catch will be executed only when the matching exception has been found. But the finally block will always be executed. Doesn't matter if there is an exception or not an exception. And we use this kind of code, a finally block, to specify the code that you want that should be must be executed, whether there is an exception or not. So if we look at an example, we have a main method, and it's the same main method. The basic functionality we are doing is the same, that we are trying to handle the exception generated by division by 0. So in the main method, we have like 3 variables, and then we have a scanner class to get an input from the keyboard. So instead of having fixed values, we want to input the values of A and B from the keyboard, and then we check the value of B. We enter the value of B, and then we compute the result by dividing A over B. And if the value of B is 0, we expect that arithmetic exception will be thrown, and we have defined a catch block to catch this exception. And within that catch block, to handle this kind of exception, what we are doing is we have written a do while loop. Why do while loop? Because we want to get a value of B. This while loop will be keep on executing until a user enters a positive integer value other than 0. If it enters a value of 0, the program will ask to do the value, enter the value again. And as I told you that you can have multiple catch blocks. So one block is to handle this divide by 0 exceptions. Another block is, since user is entering a value from the keyboard, so instead of entering a numeric value or integer value, because for division we require a numeric value, however, user might enter a non-integer value, it might enter a string value, and if it enters a string value, the system will throw this input mismatch exception. And to handle this kind of an exception, this exception is in the java.util package, and it says that thrown by a scanner to indicate that the token received does not match the pattern for the expected type. So for example, if you are expecting an integer type value, but a user, by calling this sc.nextInt, but a user enters something like a non-numeric or a string value, so we have another catch block. And what does we do in the finally? Because here we tried in the try block, we try to get a result, but in case if there is the user enters the value again, so because if the value enters a value of 0, user enters a value of 0, so this statement will not be executed, because here we get an exception. And to handle this exception, we have this catch block, and here we ask the user to input the value of B again. So we have a useful method. For example, 0 is not allowed, please enter a positive integer value, and then we read that value using sc.nextInt, and we keep on checking until the value is not equal to 0. So, and then since we have not, in the case we have got the value 0, the exception was thrown, we got another value of B, and then we want to compute the result again. So where we can do that? We cannot go back to the try block. So in that case, we can use the finally block, because we know that finally block will always be executed, doesn't matter if there is an exception or not. So, and we compute the value of result again, and we display that statement. And also we will see what other purpose you can use the finally block. Yeah?
Sir, in case of no exception,
Yes.
result will execute 2 times.
Yes. Yes. So you can,
Try from and
yeah,
then
you can, yes, nice question. And in that case, you can simply comment that one. So there is no need to compute result over there as well. Good point. So let's see now if we run this one. If we enter the value of 5, and if we try to enter the value of B as a 0,
You need the first function.
yeah, to generate, yeah. Otherwise, we will not be able to catch the exception. So we need that one. But that's true that if there is no exception, in that case, this statement will be executed 2 times. So it will override, but it will be the same value, because if there is no problem here, the catch block will not be executed, So the value of A and B will remain the same. There will be no change in the value of A and B. So if you enter the value of A like 10, value of B like 0. So what happens here, if I put it, when we go on this part here and we try to divide this, but the value of B was 0, so it generated an arithmetic exception, and that arithmetic exception was caught by this catch block. And in this catch block we have this do while loop which keeps on asking the value until the value is not equal to 0. So, and if you try to once again enter the value of 0, because when it goes here and it checks the condition while B is exactly equal to 0, yes, condition is true, so the loop will keep on executing unless you don't enter a value other than 0. So now if I enter the value something like positive, 10 divided by 2 is equal to 5. So from here it will, from the catch block it will go further to the finally block, and in the finally block it makes this, the first statement is that we have a result, and then it prints the result divided by. Okay, another case of this might be if we run it again and we enter a non-zero value. So in this case there is no problem, no exception was generated, program was executed successfully. So we computed the result here, and then we go into the finally block, and here just to avoid this condition, if you don't want to check, I mean if you want to avoid this, you can check here if, yeah, but I think you don't need to make an extra check here, you can go with it that, because even if you make a check again, the value of B will be, when you take another value, it will remain the same. But then if you see that in this case no arithmetic exception block was executed, and also the mismatch exception block was not executed. But if I comment this block now for a while and execute this code again, enter the value of A 12, value of B something like non-numeric, we got another, no, maybe I have to comment this one as well. No. And run this again. What is happening here? Let me see. Result, try. Yeah, catch. Ah, yeah. No. Yeah, exactly. Arithmetic exception. Yes. To avoid this, what I did is, like, instead of putting the value of A, I made the check on a value of A, which we have entered now as a non-numeric value, because when we go here if we make the value of b as a non-numeric value, then on this operation, before throwing this exception, it already finds the exception of type arithmetic exception, and it throws the exception, this kind of exception over there. So in other words, if you want to avoid that problem, so what I did is I tried to enter the value of a, which is not integer, and in that case, so if you don't enter the value of a, it's not an integer. So this statement a sc dot next int, it will generate an exception which is of type mismatch exception, and then it will go to the catch block, and here the catch block doesn't match with the arithmetic exception, rather it matches with the input mismatch exception. So it executes the code here, and it asks you to provide the value of, okay. So this means that we could have multiple exceptions, and we could have multiple catch blocks, and then we can have a finally block, but it's not necessarily to use both the blocks. You can use either the catch block, or you can use either the finally block, but you cannot use try as a single block. The try must always be used either with the catch, at least one catch, or you can use more than one catch statements, or there must be at least one finally block. Okay, and you cannot use catch or finally without using the try block. So there must be association between them. Yes.
I have a general question.
Yeah.
Try blocks are atomic.
Yes.
They are atomic.
They are atomic. Yeah, you can use them, and you can anywhere within a method. Then another feature that is provided by Java, that's not exactly to handle the exception, but some way to declare that if you are not handling an exception by using the try, catch, or the finally block, but there is a chance, there is a likely that a method will going to throw an exception, then you must need to specify that in the method signature. Okay. So if a method is capable of causing an exception, but it doesn't handle the exception, then the method must specify that this method will likely is going to throw an exception. And how can you do that? The general form of this is that when you are defining your method, after the method parameter list, you specify the type of exception which is likely to be thrown by this method. And here you can have more than one exception. If a method is going to throw more than one exceptions, then you can specify more than one exceptions through a comma separated list. And why this is important? This is important because you have written a piece of code which you know that in this piece of code there is a chances of exceptions, but the method is not handling an exception. However, if you don't specify this, then the users of this method will have no idea. If you have written a method, and if you have given that method to some of your colleagues or some of your customers, and you want that the different customers should handle this exception by themselves, instead of you providing them a customly or your own definition of how you can handle the exception. So in that case, you can use the throws class. And the throws class, it just tells the compiler that we know that we are aware of this mechanism, that this method is likely to have an exception, but we don't want to handle that exception. We want that exception handling mechanism to be delegated to our customers. And you can do that by specifying this after the method signatures. So for example, if you have a main method that you are using to read some information from a file, but you know that that file could not be may not be found. So in that case, you can specify that using the throws class. So for example here, in this main method, we are trying to read some information from this file. However, there are often chances that there are some problem with the file, that this file doesn't exist at this path. So for example, right now, yeah, since I'm using the computer over in this room, and I don't think that this path is correct according to the data structure here. So if you run this program now, there will be an exception, file not found exception. But we are not handling this exception. And if we are not handling this exception, and if you don't want to handle this exception, that's okay. But then, if you are not going to what it means by handling an exception? Handling an exception means that you have defined your try and catch blocks, and within the catch or finally block, you have specified the code to handle that exception. But if you don't want to do that, then you must have to declare that in the method definition. Okay, so now, for example, instead of, maybe we can find some file over here that we can use. Yeah, I just create a simple file now. No. Yeah. Just give me a second. I would like to test this one. Okay, now let's try to find if this one. Okay, so as we told you before, that the exceptions are only thrown when a program finds an error or an abnormal condition at runtime. If it doesn't find an abnormal condition at runtime, then there will be no exception. So before, in this code, we have specified a file that the path was not correct, or the file was not existing here. So for example, if we change the name of this file here just to temp.txt, since in this case this file is not placed over there, so when you run this program, there is no compile time error. But when you run this program, the runtime system will try to locate this file. But if this file has not been found, then the JDK compiler will there is written in this definition of this file class already, but that if it doesn't succeed to find the file, then it must throw an object, exception object, of type file not found exception, and we have specified this using this throws class. So if you run this class now, you get an exception, and in the exception it tells you that it is the file not found exception, and the system cannot find the, if you go down further, you can find the message that the system cannot find the file specified because this file doesn't exist over here. But if you provide the correct path here, then of course the system will find the error, then there will be no problem here. Okay, this example is just using that you can read any file, text file, and then it displays the words in that file. And then from Java, since JDK 7.0, there is a new form of try statement, which we call try with resource statement. And the try with resource statement is that instead of you can use this statement to specify one or more resources. What is a resource? Resource is like any object that must be opened or closed at the end of the try. For example, we were using, if you look at in this code, in the previous example, this file object, this is a resource that we were using to read data from the file. However, there is another way. If there is another example of the same thing over here, I just need to copy this path. So here in this file again, what we are doing is that the file, the class name is read file, and once again we are trying to read a file and then print the information and also count the words that we have read over here. Okay, but here if you see that we have specified the resource, the file, in this case the file, outside the try block, and it's also recommended that if you have opened a resource, then you must need to close that resource as well. And we normally use the finally block to close this kind of resources. If you have opened or used a resource, but you are have not closed that resource, then you get this kind of a warning over here. For example, in this class we are using this scanner kind resource SC, which we have opened on the system input stream to get an input from the keyboard. However, in the whole program we have not closed this one, so that's why we are getting a warning that the resource leak SC is never closed. What we can do is that we can use the finally block. That's another use of the finally block, to close all the resources that you have opened in your code, because we know that the finally block will always be executed when we have executed the try block. So similarly, we have here this file scan, and we then use the finally block to close this file scan block. So but then another option to manage these kind of things by itself is that we use this try with the resource statement. And try with the resource statement allows us to close the objects by automatically. We don't need to specify the close statement in the finally block. And the syntax for that is, after try, within the small brackets, you need to specify the resource that you want to use in the try block. In that case, if you are using a try with the resource statement, then you don't need uh, to close that resource, because the resource will be closed automatically when the try block has been executed. So this is a new feature in Java. So that's, I mean, that's not really important. It's up to you if you want to use the old way that you define your try, a simple try block, and then you use the finally block. That's okay. You can do it with that way. But if you want to manage, if you want this thing that if you don't like the finally block, or if you don't really need a finally block, you only need the finally block to close the resources, then instead of using the simple or the regular try block, you can use the try with a resource statement. So that was few important things about exception handling. So in short, what is important about exception handling is that you should know that how you can handle your exceptions, and you can handle your exception using this try catch and finally blocks. And whatever code that you want to monitor for exceptions, you should put your code within the try block. And then if you are expecting 5 different kind of exception in your code, you can put 5 different catch blocks after as a follow-up of the try block. And in that try block, you can that catch block will be executed whenever there is an exception thrown in the try block. And then if you want some code that must be executed, and that for that purpose you can use the finally block. Next part of the lecture that we are going to discuss today is unit testing with JUnit. But I think we will take maybe 10 minutes break, and we'll continue with after the break. Okay. Okay, yeah, now it's working. So in the second part, we will learn about unit testing, and we will see what software testing in general is, and what is unit testing, and how can we use the JUnit, which is a tool or set of library classes provided for unit testing in Java. So first of all, there might be a question that what software testing is. As we know that software development involves a number of different phases. That we begin with the requirement specification, and there is analysis phase, design phase, implementation phase, and so the testing is one of those phases during the software development. And the purpose of this phase is to make sure that the results that we get are actually the results that we want. Okay, so there are several definitions about the software testing. It's a process of executing a program with the intent of finding errors. So one purpose of software testing is to test our program to find out, to identify the logical errors or any other kind of errors in the program. And so the basic thing about the software testing is to check whether the actual results match with the expected results or not. So for example, if you have written an algorithm to sort an array, and before delivering that algorithm to the customer, you must have to test that algorithm whether it performs the function for which it has been designed or not. So if you have, and that's not only for the software, I think it's true for any product in general. So if you have designed, if you have developed a chair, before handling that chair to the customer, you would like to test that chair. Is it strong enough? Is it soft? Is it relaxable? Or you can use it? So it's a process of that. It's an activity or a process during which we check that the software is meeting all the requirements or not, and if the results that it provides are actually the results that we want or not, and whether it satisfies the requirements or not. Okay. So if we look at a software system, particularly an object-oriented system, so we know that a system is composed of a few subsystems, and then within a subsystem we might have several different components, and within the components, for example, an example of different components in Java is like we have classes, and within the classes we have various methods and fields and attributes. Okay, so and all these different components and subsystems and methods and classes, they together work to make a whole system, and that's important to know. I mean, when you are testing a software system, so there could be one way that you test the whole system, another way could be that you test the different subsystem and different components. So the testing could be performed at different levels. So we will see what are those different levels. And that's again, as I talked in the beginning, that a software development is typically consists of several phases. So some of the very common phases are these requirement specification, system design, subsystem design, and implementation and maintenance. I will not describe them in detail because I expect that you all are familiar with these different development phases. And if we look at testing, so the testing is normally performed either during the implementation or after the implementation, but that's not really necessarily. You can start testing of the design. You can start planning your test cases and how you can design your test cases together with your system design. Okay, so and the most advanced or the recommended approaches nowadays is that, for example, if you are, I don't know if you're familiar with the test-driven development. The test-driven development is like where you define the test cases first, and then you follow the test cases to implement or to develop the system. And coming with the different components of the system, we have different kinds of the different types of the testing. The most commonly used or the simple kind of testing is the component or unit testing. in this kind of testing, instead of testing the whole system or a subsystem, we pick or select the smallest components or the different components, and we test those components individually in isolation. Like if you have a methods or if you have a component that provides you with the sorting functionality or that provides you with the search functionality, search method. So you take that component and you test it individually that whether it fulfills the whether it meets its requirements or not. And then we have integration testing. And in the integration testing, as the name indicates, we integrate multiple components, and then we test those components together to find out whether those components work together or not. So, for example, if you have a system which is composed of 5 different systems, subsystems, or 5 different components, and each of these components individually work fine, but there might be a problem when you combine those systems. So they might not be compatible with each other. Their provider required interfaces may not be supporting each other. So this kind of testing you do, we call this integration testing. And then there is another type of testing which is known as alpha testing or the release testing. And this testing is performed if you are working in a software development company or as a software developer, and if you are developing some software system for a client. So and when you have developed the system, before delivering that system to the client, you first do an internal testing. So you test your system inside within your own organization. And this kind of testing is known as alpha testing. It's like an alpha version and beta version of a software system. So when you have a software system ready and you want to, before delivering it to the customer, you want to test it. And then we have a beta or acceptance testing, which you test together with the customer. So, and this is also like, kind of an advanced form of integration testing. And in the integration test and the alpha testing, where together, and this kind of testing you perform together with the actual customers in their own environment. So the difference between alpha and beta is the alpha testing is performed within the software developers company, but the beta testing is performed on the client side in the actual the real-time environment. And then we have a regression testing. Regression testing is, for example, if you have developed a software and then you have handed over to the software to the client, but after 2-3 months, 4-5 months, there is some change in the client wants to change some modules within the software, and then to fix that change, or maybe there is some bug, some virus detected in the codes, or some problem detected in the code, and then you fix the code. But it is also important that after fixing the code or after changing your code, you do the testing again to make sure that your program or the software, the update to your software works correctly. And this kind of testing we call regression testing. So the testing that takes place after a code has been changed. It might be a change in one module. In that case, maybe you can do first the component testing or the unit testing of that code, and then you do the integration testing as a whole. And then another kind of testing is like performance testing. We do this testing that to verify the performance or the quality. For example, it might be that your software is working fine. There is no problem with the correctness. It meets its requirements. It satisfies its requirements. But then sometimes there are some quality issues that your software is working, but it is working very slowly, and it's not very interactive, or it's not. So this kind of and testing where you test the performance of your system, that how long it takes to perform an operation, or how long maybe the resource, how much resources it is consuming. So maybe your software is consuming a lot of resources, and of course if it's consuming a lot of resources, it might be affecting the other systems. So this kind of testing we call performance testing. And then we have a few other types of tests. We have like independent testing, black box testing, and white box testing. Independent testing is, as the name indicates, this kind of testing is performed by another party or another person than the person who has written the code. So for example, if you are working in a company one way is that you write a code and you test your code by yourself. But the problem with this kind of system is that maybe you as a user could not see the problem in your own code because you have written it yourself. So you will see that you will like your code and you might be biased towards your code. So you will not be able to identify your errors quite easily. It's same like if you have written an essay or if you have written a report, you might be not able to find your own errors. But if you give that report to some of your colleagues or some of your another friend, that friend will find a lot of errors. So it's like different perspective. So this, to avoid this kind of problems, it is always recommended that you should have an independent testing where you write a code and then you, in the best of the world, you should ask some private organization to test your code. But that might be costly because the private organization will ask you to pay for that. But on the other hand, maybe you can ask if you are working in a large company where you have a number of different teams. So you can ask somebody from another team or some another department that he can look at your code and he can test your code. And if you can't do that, maybe you can ask someone within your team to test your code. Okay. So this kind of testing, when somebody else is doing the test, is known as an independent testing. And as I told, the advantage is that it provides you with a better opportunity to find out the errors. And then we have a black box and the white box testing. The difference between the two is that in the black box testing, the tester, the guy who is testing the code, he doesn't have an access to the internal implementation details of the code. He only knows the interface. What does interface mean? He only knows that what does that component provides and what does that component requires. So he doesn't know what is internally happening. So for example, if you're talking about if you look at here some method, not this one maybe. No, not that one. Yeah. So if we talk about this divide method, if you consider this as a component, so the interface of this component is that it takes two integer values and it requires two integer values and it provides us with another integer value. Okay. So the provides and the requirements and the functionality that a system provides and the values that it requires as an input, they are known as the interface of that component. So however, in the black box testing, the tester gets the code as a kind of a black box. He cannot see the implementation inside details, what is happening. He will have no access to the internal code. So he will only know the input and the output of that component. And the advantage of this this kind of testing is that it allows you to do the independent testing. So for example, if you want to have your implementation as a private, you don't want to leak out your implementation details, so you can use this kind of approach. But the problem with this approach is that it is almost impossible to make sure that every part of the code is working, because it doesn't test the internal details or the internal implementation. It only tests what is provided and what is required, only the input and the output. If the component is working, if you have provided with the correct input, will it provide you with the correct output or not? On the more detailed level, we have this white box testing, in which the tester has a complete access to the whole component along with the internal details and the code. So the test designer has access to the source code and can make sure that every part of the code is tested. Advantage is that we can have a more detailed and comprehensive testing here, because the tester can go and look inside the component. However, the problem with this kind is that it is usually not practical especially if it's like a large system. If you are dealing with a large system and if you want to do the white box testing and want to make sure that every single piece of the code has been tested, it means that it will require a lot of time and a lot of more resources. And if you have like a code that consists of millions of lines of code, and making and doing the white box testing for all those thousands of different components and millions of codes will not be an easy task to do. Okay. Next, another perspective of the test is that testing, I mean, when you have tested the code, it doesn't mean that it doesn't give you any guarantee that there are no errors in that code. The only thing that it gives you is that there is, I mean, you can use the test to show the presence of the errors, but not to show that there are no more errors in there. So you can use the test to find out the errors, but you cannot give any guarantees that since we have tested this code, there will be no errors in that code, because abnormal conditions can happen, because you cannot have 100% assurance that we have tested this code and now there will be no problems. Okay, you should not go for that. Instead, the idea of testing should be that we should use the test to find out the errors and to show the presence of the errors, not their absence. That's a common principle. Why this principle is important? Because we might have an infinite set of input, and we can have in a software system we can have a number of different scenarios to use the software, and one user may use it in a different way, and depending on the number of users, if you have maybe 1 million users, each user may have its own way of using that software system. So, and it means that testing all those possible scenarios will require a lot of effort. We cannot test all possible executions. We cannot prove, thus we cannot, if we cannot test all the possible scenarios, and if we cannot test it for all the possible inputs, that means we cannot provide guarantees for the absence of errors for all those different scenarios and input data. Okay. Another approach, if you want to go, I mean, if you want to assure that there is no presence of errors, the more concrete way is to do a verification. And verification is normally it involves formal methods, and formal methods these are like mathematical techniques to test the programs. And however, the problem with this approach is that it's extremely time consuming and also not easy to learn and apply. So it's very rarely used in practice. So then, I mean, if we cannot, I mean, if by testing a software we cannot, guarantee the absence of errors, so why then we should do the test? Okay, so, and the reason is, even though we cannot guarantee the absence of error, however, by testing the software, we can show the confidence in the software. We can establish some level of trust in that software, that we have tested this software, and for this obvious scenarios, for this number of scenarios, this software works. So it's not a crap piece of code that will always crash. Rather, it's we have tested it for this number of scenarios and this number of input data. So it means that when you have tested the software, you have improved its rating or its quality of use. So there are two major reasons to use to test your code or to test your software. The first important reason is to detect the errors instead of preventing the errors. I mean, you can prevent the errors only if you can detect them. If you cannot detect the errors, it's hard to prevent them. Okay, so the first step is to detect the defects, and if you have detected them, then you can come up with the solution to prevent or solve those problems. And then we can also, another benefit is that we can use the testing to show that the code that we have written actually meets the requirements, and it actually performs the task that we want to achieve. Then another question could be asked, that when should testing be done? So there are, I mean, three obvious cases. One case is one situation is that you should test after developing, but that's not really recommended. It's kind of an old-fashioned approach, and usually it's used by students in academia. So they used to develop their system first, and then they write test cases to test those systems. However, the more used and practical approach in industry is to perform the testing together with the development. So when you are developing, you perform the testing at the same time. So you write a method and you write a test case for that method and you test it. And that's the recommended approach. And the advice, this is a recommended approach because it allows you to detect the errors as early as possible. Otherwise, for example, if you have written if you have spent like, for example, 3 months in developing a system, but you have not tested it, and in the end, after 3 months, 6 months, you find that there are a lot of errors, that's not what you was wanted to achieve. So that means that you will lose a lot of time and lot of resources. But on the other hand, if you are doing testing and developing together, so whatever if you write a one class or a one method and then you test it, that will guarantee you that you are going in a right direction. And then another approach is that before implementation. So you can write your test cases, or you can plan your testing even before developing a software system. It could be sound like maybe a crazy idea that you have not developed something, but you have already written a test case for it. However, it is quite useful. And there is a development paradigm with the name of extreme programming, which really advocates this kind of style. And another name for this kind of testing is the test-driven development, where you first define test cases, and then you use those test cases to develop your software system. Okay. However, whatever kind of the approach that you use, the basic objective should be that we should be able to detect or find the errors as early as possible. And I would recommend that if you cannot follow this approach, you should at least be following the testing together with the development. And how should you design your test case? So here is we have some basic steps to design a test case. The first step is that to design a test case for your software system, you should identify features in your software system. The features could be, for example, if you talk about the different social media applications. So, for example, WhatsApp or Facebook. So you have different features over there. For example, you can share your post, you can comment on the post, you can like on the post. So these are all different features. So you should first identify different features of the software systems. And once you have identified a set of features, the next step is for each feature, you should find an input data, that what input data will be used to use that feature, and against that input data, what will be the output. Okay. So for example, if we have this method to divide, then the two input parameters A and B, the values like 5 and 2, these are like input parameters, and the result that we get as a result of the division is the output data. So you identify for each feature, you identify the input, you identify the output, and these together, the features and the input and the output, these are called a test plan for a feature. Okay. And we also have a terminology fixture, and the fixture indicates basically the input data. So the input data you can also call a test fixture. So once you have done with these steps, then you can continue with, you can test your features one by one using the input data and then matching with the output with the expected results. And then we have, in the beginning we have seen a few different types of testing. However, in this course we will be focusing only on the component or unit testing. We will not cover the integration and the release and the other kinds of testing. And in the component or unit testing, as the name indicates, this kind of testing is performed for a small program units or the software system units. And these units are generally like data structures, different data structure, list trees, and sets. and yeah, it could be different algorithms, could be any other entities that you are using in your program. Okay. In other words, every part of the program that can be tested in isolation is a component. So, okay. So whatever part of your program that you can test uh, separately without any dependencies on the other system units is a component or a unit. And what is the goal over here? The goal over here is that we should have some kind of assurance that the component is working properly. Okay. So once you have tested that component, you can say that I have tested this component and this component works perfectly with this kind of input data. Okay. And when can you do the unit testing? The best strategy is that you should do either during the implementation or immediately after the implementation. So you should not wait until the whole system has been developed. Okay. And who does the unit testing is normally done by the developers themselves. So if you but in ideally I would suggest that you should ask somebody else to. But of course, when you are learning something, every other student will be doing his own testing, so you will not be able to find an independent guy to do the testing for you. And since if the developer is doing testing, unit testing for its own code, then it means he has an access to the code. And when you have access to the code and all the details, so that kind of testing is a white box type of testing. So here we have an example. So for example, we have a method, sort method, which takes an array of type integers, and it's the input array might be not sorted. It could be like in a different order, but then this method sorts the array in ascending order. So there could be different solutions to test this method or component. One approach could be that we do a complete exhaustive testing, where we test all the possible cases, all the possible input values, and all their combinations. But it doesn't sound very practical, because to figure out number of different integer arrays will take a lot of time. So how can we do then that? Instead of testing all the possible cases, you can come up with a strategy. And in the strategy, it is recommended that you should test for the extreme cases, and you should test for the maybe the maximum, minimum values, and the values within the boundary. For example, in this case, if it's an array of integer, so few extreme cases might be like you test it for the empty list. Okay. A general tendency in a student testing is that if they have written a method, they will just go for a regular cases like an integer array of size 5 or 10. That's okay. You should always test for a regular or standard input, but you should also try to find out the problem areas and test your component or unit for the problem areas. So because when you have tested it for the problem areas, you will find out the more problems, and you will see that my component, my unit is doing good for the. So we have so far one suggested strategy over here is that whenever you have an array, doesn't matter if it's a sort method or if it's something another method, so you should test it for an empty array. So you see how does your unit behave with an empty array, or maybe a very small array, or maybe for a very large array. Like here you have only one value, here you maybe have a thousands or 100,000 of values, or whatever it allows. And you can also test it for the even and odd size arrays, because often the different algorithms, they behave differently when it comes to the even and odd sizes. Okay, so that's one suggestion. And another suggestion is that you should, as I told earlier, that extreme values, and the extreme values mean the both the minimum and the maximum cases. Okay, and then continuing with the unit testing. In general, when you are trying to choose the fixture, and the fixture means the input data, test all extreme cases, and you should try to not only if you have selected few standard cases, that will be okay. And also you should also test the scalability. Scalability means how does your unit or component behaves in case of a larger data or larger methods. But you don't need to do that for a simple methods like get and set, because these methods are not doing any complex operation. They are only setting and getting the values. So there is no use of doing scalability tests for such kind of methods. Yeah, and in the if you are doing the white box testing, yeah, ideal will be that you should test every method. If you cannot test every statement, you should at least be able to test every method, and then make sure that every statement is tested. But that's kind of, you can say, a very optimistic or the realistic goal, but not very practical. The practical goal is that you should, if you're doing the white box testing, if you're doing of course, if you're doing the black box testing, that will not even be possible. And then, yeah, as I said in the beginning, one of the suggested approach is that whenever you have implemented a method, you should test that method. If you return a method M1, you should define a test for that method, and then you continue on, so on. Okay, but on the other hand, we already talked about this extreme programming approach, where it says that you should write a test method first and then implement the method. But there are both strong and negative points about this approach. Those who support the extreme programming, they advocate that writing first test cases first. They allow you to have to make a good preparation, because then you know the problem areas beforehand, and it means that if you identify the problem areas beforehand, you understand the problem domain in a better way, and you can write your code in a better way. And once you have done with the implementation, you have already produced a tested and verified piece of code. But on the other hand, the problem with this kind of testing is this could be used for a small level applications or the system. But however, if you have a larger systems, it might be not very scalable, because designing unit test first for a larger number of systems and then following it might be not very practical. Okay, so that was some general information about software testing, and the next thing we have is the JUnit. It's a framework that has been designed to do the testing of the Java classes and the methods. And we will be, and the reason we are using this is because it's quite easy to use with the Eclipse, especially. And the latest version of the JUnit is JUnit 5, but it's okay if you want to use JUnit 4. Here is an example. How can we use this JUnit testing? So here we have just a simple method, multiplication method, which takes two integers and gives us the result. However, it performs the multiplication in an iterative way, and before performing the multiplication, it checks the values. And for example, it's not really necessarily, but just to demonstrate it, it checks the second argument, and if the argument is less than 0, so it throws this exception, illegal argument exception. So this method requires that the second parameter must be a non-negative, and non-negative means that it should be greater than 0. And if it's also equal to 0, then it should, yeah. So we have a recursive approach here. So if you see that this method is calling itself again to compute the values, and then to test these methods, we have defined some extreme cases over here. So some standard cases. So here we have the extreme cases with the lowest value or the minimum values, and then we also have extreme cases with the larger values, and we have some standard cases, and then we have some cases for the exceptional. And so just to see that how does this method behaves when there are an exceptions. Okay, so it would be better if we look at this in Eclipse. So I already have defined, yeah, so here we have this myMath class, so which has this multiplication method, and then to test this class we have written a separate test class. In Java, it's normally recommended that you should write a separate test classes, and a general convention is that you should use the name that ends with the prefix test, so that you know that this is a test class. And if you see in this class, it looks like a normal Java class. However, you see that the methods are marked or tagged with this annotation test. So these test annotations, these are the annotations provided by the JUnit library, and this tells the Java compiler that the method tagged with this test is a test method or a test case method. And in this case, the test method, we have these statements assert equals, and this assert equals statements, they are provided by JUnit library class with the name of assert. And if you note here, we have imported this assert class together with the keyword static. And the advantage of, why, if we use this as a static, it allows us that we can use the methods of this class, because these methods are static methods. So we don't need to specify the class name. Otherwise, we have to specify the class name. Yeah. The method assert equal is undefined because it cannot find it over there. However, import, it's already there, but I don't know why it's not finding it. So if we do not specify a static over here, we have to specify assert together with all these assert equal methods. These assert equal methods, they are provided by this JUnit assert class to test. And what does this method do? These methods take assert equal method takes two parameters. The first parameter is the expected value, and the second parameter is the actual value. So for example, if we want to test whether this multiplication method, when we multiply 10 with the 0, what should be the result? If you multiply 10 with the 0, the result will be the 0. Okay, so that 0 is the expected value. So we put the expected value here, and then we call the method with those values 10 and 0. And if we want to test, that we are testing for the smallest value, extreme cases, with the minimum values. And then since we know that, if we want to check that, if we multiply 10 with the 1, the expected value should be 10. Otherwise, if the method returns anything else, then this assert statement will create an error. It will flag an error. So the test will not pass successfully. We will get an error statement. So just to give you an overview over here now, I'm coming back to the static part, because it makes more sense that instead of writing assert dot every time, we just put static keyword, and then it allows that we can use these assert equal methods from this class without writing the class name. Now if I run this you see that we have a different behavior over here. And another important step is, I think, yeah, I should maybe talk about that before. If you're using Eclipse, before using the JUnit, you must need to configure your the build path, the class path, and you must have the JUnit jar file at the class path. Okay. Otherwise, you will not be able to use these JUnit test classes or the assert classes. And there are different ways to do that. I mean, the one way is that you install, you download the JUnit separately and the jar file, and then you add that jar file to your build path. And you can do that, for example, for this project. If you go here, and then if you right click, and here you find the build path, and in the configure build path, although I already have this JUnit over here, so, and if I remove this one in the libraries and apply and close, now if I go here, I got an error because my Eclipse projects, I have removed this JUnit library from my build path. So now the Java runtime, the compiler is unable to find these imported classes. So in order to use these, you must need to download the JUnit and then add the jar file to the build path. Nowadays, most of the Eclipse versions comes already with the JUnit, so you don't need to download separately. And an easy way to add the JUnit library to your project is you just right click on your project. Is it the next class waiting outside? Okay. And then you have to, if you go to the build path and add libraries, and here you can find the JUnit and you add it over here, and then you click on the finish part. So in this way you will be get access to this the JUnit libraries and different classes. Okay. Okay, I think although we have few more slides, but as we're running out of the time, so we can talk about this maybe in the next lecture. But meanwhile, I will upload the lecture notes to the Moodle, and you can before the next lecture you can look at those lecture notes, and if you have questions, you can definitely contact with me. Okay.